Thank you for having me. My name is Amandeep, and I work as a senior software engineer with Hybrid Greentech. And before that, I've been working in banking, principal IT consultant for event streaming projects related to Kafka. And these are the 10 best practices basically which I have put here, learned out of experience, learned of like hard times, learned out of crazy bad mistakes, and realizing, going back and forth. So these are like those 10 practices, not in any particular order, but they are all equally useful, I will say this way. To get started, like why we need event streaming, or the event streaming is like anything happening in the world, it affects the business. If a business is running 24 by 7, it needs to respond to probably those events. And we are not talking just about stock market volatility and fluctuation in price and executing those trades. We're talking about like new products which are emerging around us, like flash loans in crypto space. If you're watching in the DeFi universe, smart grids within an electricity distribution, with who's contributing to the grid at what time and at what like a 250 millisecond you have to kind of measure the voltage, and based on that the relay has to act upon. And of course e-commerce, like web events, transactions, all the user interactions. If you can find out the user is having a particular behavior repeatedly, like can you take a quick action, can you have any. So basically they are all the cases for event streaming. Now coming to there's one argument which comes like, oh, do I invest in streaming? I can store them, I can produce, consume, like the typical classical way. Do I need streaming if I have storage? Maybe not. You can have data lake, database, time series database, or another data warehouse, but what about your data shape, size, criteria, querying properties, data cleanup, how big that responsibility will be? And come on, like how has been existing data warehouse helping you? Do you require to segregate those events once you have collected? Then why don't you collect in a right way, a right shape, or stream them? Yeah, so some terminology I think most of the audience would know here, but like topology, as we call in event streaming, is a graph of stream processing nodes. Basically, there's like the pieces of logic which are in a certain sequence, which is a topology. So there's like a source processors, there are processors, processing nodes, and they are like sync processors. And then the concept of mediator EDA versus broker EDA, I believe you have a kind of basic understanding. And CQRS, command query response segregation, because for the same data you can have a read heavy interface, and for the same data you can have a write heavy interface also. So command and query are segregated. Event streaming approaches, let's also kind of like throw the area here to discuss. Lambda architecture, we discuss all the time. Oh, it's a real time batch. Then this is something called kappa architecture. Kappa is basically like it has a characteristics of both batch and real time, but I'm not getting into discussion of those here, but this is you must be hearing around. But everything with all these architectures and data warehouses and data lakes goes wrong until number one out of 10, setting expectations related to events. Why are we doing this? Okay, events are coming and we're gonna act upon them, sure. What is the order of these events? Do we receive the events in the same order as they are occurring in the real world? Reliability, availability, guarantee of delivery, they look like computer sized terms, but they are actually business terms here. And then if we look more, is guaranteed deliveries, and kind of another discussion itself. Event volume, how many? Event priority, which event is better than the other one? Event size, what's the size of payload coming? How much I should plan for? And if I have to act upon quickly on certain event coming, it better be lean so that I can parse it quickly. For example, an external event, or maybe you have to sync up with some other event in the outside world to call it actually an event. maybe it was a false alarm, so maybe it's not an event. So setting all those expectations there is the most important thing, I will say. I might repeat the word most for all the 10, because 10 I find are our kind of finds. So setting expectations is the first one. Then keeping in mind that you are not trying to build a legacy application again. What has been a purpose of dumping data in data warehouse, or a kind of like a big chunk, mainframe maybe, or anything? How about splitting the data into domains? Then you have a read heavy and write heavy way of approaching the same data of that domains. Maybe that's the first start. It's not, we are not even defining event set. We are first defining those blocks, those domains, which will have their data changing based on events coming. So those deconstructing those domains and subdomains is very important when we classify the events and create those event dictionaries which correspond to changes in data dictionary. Being aware of the business Gerunds. Gerunds are like a complicated relationship and a fun way to be said, but basically from ER diagramming perspective, as you say, like they are the composite entities, and that's a thing where sometimes some data ownership responsibilities fall between the chairs when you kind of split the domains, and then you cannot really find, because it's a composite entity with some attribute value from this domain and some from this domain, and is useful for some business purpose which is not applicable to these domains. It's a kind of like a composite entity who will maintain its data ownership. So that also kind of things like if an entity of a customer relation with a bank or customer relationship history is received, which kind of contains the customer transactions and customer data, and we are talking about customer is one domain and transactions another domain, so customer transaction history. So this is a gerund. So how do we maintain that? Like if this data object has to be transported, like whose responsibility is that? If a certain event has come and it has to carry this as a payload or a sub payload, who is the kind of a data change owner or responsible domain? So such decisions also you gotta get into. Not over investing in a single platform. Maybe the slide will be a slight misnomer, but what I'm actually trying to say is don't be so hard on yourself, like we have this technology and that's all we got. So this typically happens with when you're streaming events in Kafka, for example, and the data is going through like from one topic with certain processing, enrichment, aggregations to another topic to another, a typical like how a topology works. And when I say that, like I will quote my previous organization and we're like, our database in SQL, sure, but it's JSON data passing, transforming, JSON aggregations, JSON field value injections, and then it lands on a new topic, sure, and it has a state store, intermediate store also, and that intermediate store now is SQL. Wow. So this JSON, which is still intermediate, gets turned into a relational row to go into the SQL database, read again from there, converted to a JSON. So what I'm trying to say is like SQL and no SQL. So have a pragmatic decision like, yeah, for intermediate topic storage, I'm fine with no SQL. What's so wrong with it? Because maybe if I say my hard business database is SQL, so sure I will reach there, but I will not try to kind of like do a vendor comparison talk about Confluent, Apache Kafka and so on, Red Panda, Amazon's MSK, somewhere it is there too. Each has its own pros and cons, so kind of measure. Maybe you need more than one. For example, if Red Panda has a single binary and it's a Kafka API compatible, and you have already kind of implemented Kafka in your system, and because Kafka brought a lot of JVM in your technology stack, and your new developer hires do not like it, so that Panda is kind of like can go very well with existing Kafka. Same thing if you're using Confluent And if you are not just doing the streaming wave with the Kafka streaming DSL, and you get addicted to using KSQL, it's very convenient. You have an alternative like Materialize also, a Materialize database, which kind of gives you those materialized views on different topics, and then you can do whatever you like, just like almost like KSQL. Because people who use Apache Kafka or MSK versus those who use Confluent, they kind of like KSQL is one thing they miss, other than some kind of connectors also. So that's like go pragmatic, not over investing in one single platform. And then very important, I know I'm repeating it, developer upskilling. Developer upskilling is all about thinking in streams, like thinking anything happening in the world is like a stream. It's like if a water is coming to you, and your job is to kind of like maybe process the water and sweeten the water or something. So a typical approach, as you kind of like would pick, is like, okay, I'll pick this water and do something, I'll keep it there or something. No, you do not have that option in streaming universe. Like there's like a flood coming here. So you cut the canal, you create the tributaries, but you cannot stop the water anywhere and hold it till you process it, because it is always a data in motion. It is always flowing. So developers' mindset really needs to be up to there, that thinking that it's a streaming system. It's not kind of like a pick value of A and pick value of B from somewhere, and by the time I pick things in the world can wait. No, by the time you have picked A, B, maybe 1,000 more of them have come as well. So, and because of that topologies which you build, like those tributaries, like after this, do this, do this, and you define those topologies, and as you can understand, those are very hard to debug as well. So, and they always change based on, you always figure out there is something better can be done. And also, if you are changing the data models, like at any time from the source side or the kind of destination side, it can always change your topology. Okay, maybe some kind of a fields added, but if it is leading to continuous code refactoring on a regular basis, then probably your data modeling skills needs to be upskilled. And also the question comes about event stores or API endpoints. Should I give API endpoints or these state event store? There's no kind of like a final straight answer to it, but based on your use cases, you can always work out whether it's important to expose something as an API endpoint or not. I'll come to that, because that's something coming. Yeah. Event processing topologies debugging can be extremely challenging, as I said. So key challenging which comes with adopting any streaming platform like Kafka streaming is debugging. Reviewing a streaming technology output at end of each stage can be overwhelming. Maybe you use a stream visualization tooling. There are few for Java Universe. It can be hard to predict for your aggregation results also. If any bug creeps in during aggregation stage early, it will propagate all the way through and skew all the aggregation results. So it's peak is one part of it. For example, Kafka stream DSL operation peak, it's a kind of a system out println. And if you're a Java guy, that at every stage I'm just doing a print and seeing, and like peak is basically copy of that stream, and you see what that stream contains now after certain intermediate transforming. So again, related to topology, inefficient topology can have a lasting consequence. Nobody, I know, nobody, probably have been told also, writes a data pipeline or topology right in one attempt. Nobody. It always gets kind of transformed, changed, improvised, a better way emerges and all that. And it's therefore, like one was talking about breaking down the domains, and also important is breaking down the data transformation in simple chunks. One thing which I kind of like about Kafka over Apache Sparks, for example, is like you cannot do like a 6-way merge or 5-way aggregations and all that. In Kafka, when you're doing like you're doing always like a two at a time. So I aggregate topic one to topic two. Maybe the aggregated result now I can aggregate with topic three. Maybe that result, which is aggregate of topic one and two, aggregated and then aggregated with topic three. Maybe now this can be aggregated with the topic four. Sounds complicated. It's actually not when it's kind of a written as a neat topology code, but that really helps when you get your data transformation is broken down into chunks, because and peak operation as I was telling. So at each stage you can kind of see what's happening, that with the kind of like stream of data coming, how it's getting transformed. When those chunks are manageable and small, you have a better control on the topology. Okay, that's my favorite one here on the seventh item, dump pipe smart endpoints. It's not my own creation, it's Martin Fowler's own word. Dump pipe smart creation, smart endpoints. Like data movements should be dumb processors. It should just like put like at a micro stage. But if the data is required for something, then it should be served in a presentable, nice, aggregated way. So that is the job of when you write that smart endpoint. So this is Martin Fowler's kind of a guidance principle. It also helps an organization to have a complete control over data, complete processing logic, keep the data in the raw form, whichever way they would like to keep for auditing purposes or replaying purposes and everything. But this approach is not in benefit of vendors to sell when they are selling data products. So you can Google and find some articles they are calling the end of dump pipes. Smart pipes are the new thing, because yeah, this vendor brings with a data processing tool, and they pick data, they do some kind of a transformation or some changes, maybe for example time zone change or time zone uniform format, and they deliver. I'm just telling you, like I said, they promise a lot more kind of workflows and whatnot, fetching aggregatable data from rest of the universe and making something for you to deliver in your organization. So eventually the job of such data tool vendor is to make you dependent on that data pipe tool, which is basically a smart pipe, because there's a lot of processing they inject in that. So you will hear a lot about depth of dump pipes. Smart pipes are here, and these are the pre-created workflows, and you can create not just data transfer instructions, but you can have a whole fancy workflow. Well, it might work for some, but if you want a complete ownership, I still kind of and we talk with all these vendors all the time, and some vendors we use also for some data transformation and movement purposes. But it's always good to keep your kind of ears grounded on this principle, dump pipe smart endpoints, so that you know that what data is actually coming and what are my processing stages. So some processing stage is not obscured by some vendor implementation over there. So, and if you get stuck down with certain topology happening in one of the smart pipe, you have a better control of redoing it. If you change the vendor, or you still want to start with the raw and you found a better algorithm, better you want to split this time, so you have a better control when you follow this principle. Stateful workloads. Okay, that is something which comes to, because Kafka or any event streaming framework, we have concept of stateful transactions, stateful transformations, and stateless transformations. Stateless transformations we are not much bothered, because now these pieces of logic, the topologies, are deployed on, for example, Kubernetes pods, OpenShift Kubernetes pods. And how the distributed computing and the pods work is the pods can go down, come back up, go, like this is how it is. What about, and they are designed for stateless uh, transformations. Now, stateful workloads for a Kubernetes pod is a difficult thing. It's a new thing altogether. Then we also have state stores in our RocksDB with Kafka. You can always create those state stores. The state stores also stay under the pod. If the pod is coming back up, then where the state store is. So state store is actually, the word says state. So Kubernetes CSI is one of the thing to think about, to use about. It takes care of like whichever pod is hosting that storage, and the storage as a state store is available to you. So why this comes up again in discussion is because Kubernetes or any kind of container orchestration system, they have always been designed for stateless workloads, and whenever there's a data streaming has a lot of stateful operations, so you will always come somewhere like there. Frequent changing needs can pose challenges. There's no thing called final aggregation. There's even event streaming, where even though you kind of reach the precise timed windows and the precise aggregation functions, because changing requirements can always create situation for a topology change. Imagine a scenario where stream replaying becomes a requirement for you. Like, it should never become a requirement for you, because if you're even streaming, the stream data comes in, it reaches certain destination, and in normal circumstances you should not be asked to replay it. What if you kind of like I came across this interesting product that Panda's tiered storage. Like, its purpose is like, you can collect the data, keep in a binary format, and as long as you use our license, it's a good strategy to kind of read back the data in binary proprietary form, and it will be replayed from the topic where it belongs to. Good, but Kafka or any other event streaming system, they are not a database, they are distributed logs. And their job is to carry this information, helps you build your data streaming topology, and put the data to destination where you want to. And from there, like, you should have a complete control of read back and do something, or make a new source connector to that data state. But if in a situation your replaying, it becomes as a business requirement, no, something is absolutely not okay here, and something needs to be openly discussed. So, and such frequent changing needs can be challenging to your whole event streaming kind of objective itself. Last one, centralized ownership. Centralized ownership can be a threat. Yes, because we are talking about, we started with like defining business domains, decoupled businesses processes. Decoupled business processes, yes, allow you to kind of event stream between them, or when an outside event comes, you kind of like pull certain items to go to one domain and pull certain items to go to another domain. I can give you an example of like in banking, the customer address changes, so this notification comes. So many different processes have to kind of spin off in a bank. For example, customer master data change. Customer address change means, the anti-money laundering kind of scripts and systems will be alerted, like, hey, for this address change, something maybe needs to check secondary. Like, this, like a whole workflow. Customer data change, customer address change specifically is like, okay, customer experience team, they treat their customers nicely. Whenever the customer changes their address, what they do is they send a welcome letter home, like, hey, welcome to your new home, this, and thanks for banking with us, and this is the nearest bank branch available to you. Customer experience for the customer address change. But centralized ownership, in this case, you might concur that it would be better, but more centralized ownership can create more problems, because these are independent business workflows. We are talking about decoupling. Domain driven design is a kind of a nice approach to deal with it, but so that's why it is a more you decouple your business process from the start, more you decompose your data processing chunks also in kind of like a series of chunks, manageable chunks, And that is the approach which kind of leads you basically sum up all of my 10 points also, to come from like, here these are my source data structures processes, this is the whole topology, and this is the topology, this is how it works, and I have a complete control of all the chunks of this topology, and it delivers the final data out to certain place. So basically these are the 10 points I wanted to kind of cover. I wrote like a lot of text on slides as well, maybe because it is useful, it kind of catches the eyes, and we could be using this slides for more kind of follow-ups. Other than that, I am open to questions. Thank you.